Hello sleuths, welcome to the second episode of the Astronomy series. Today in this video I will be talking about dark matter and dark energy. So have you all ever heard or perhaps read up about dark matter and dark energy? No? Okay, stay with me till the end of this video and I will tell you. Getting back after a short intro. Now, what is dark matter? Matter which is dark? Something dark perhaps? Definitely it is dark and hence the name. And actually when we deal with the universe, we deal with dark things. Now, let's come out of this labyrinth of the dark and let's go straight to the topic. So before I get into details, I begin by saying that this dark matter is a very vast topic. It is so very vast that it is not possible to cover this topic in a few minutes video. However, I have made an attempt to enlighten you about the topic in this short video. Most of the information about it is still in the dark. Yes, because most of it is still unknown. This dark matter and dark energy together constitutes about 95% of the universe. That is 27% dark matter and 68% dark energy. Okay, so dark matter was first discovered by the Swiss-American astronomer Fritz Zwicky in the 1930s. However, modern calculations were made by Vera Rubin in the 1960s and 70s. Now what she found out was that the mass of all the stars in the Coma cluster of galaxies amounted to only about 1% of the mass actually needed to restrain the galaxies from moving out of the cluster's gravity. So that meant there was definitely something which accounted to more mass, and this matter was therefore initially called missing mass. Talking about the discovery of dark energy, it was discovered in 1988 by two American astronomers, Adam Rees and Saul Perlmutter, and Australian astronomer Brian Smith. They were a part of two international teams. Now what they did was, they measured light coming from a particular supernova called Type Ia supernovae, known as standard candles for their consistent brightness. Now these types of supernovae, which exploded when the universe was much smaller than it is today, were fainter. I mean, the light coming from it was fainter and therefore farther away than they would be in a universe with dark energy. Now this must have some implication. Yes, it did. It meant that the rate at which the universe is expanding now is much faster than it was in the past. And this was all thanks to the large amount of dark energy at present. Dark matter has never been seen. This is because it does not absorb, reflect, or emit light or any other electromagnetic radiations for that matter, or energy, which are the two essential key factors which enable us to detect the matter all around us. This light is what has enabled us to know about the majority of the universe, and its absence is what makes dark matter even more mysterious. In fact, absolutely difficult to spot and also difficult to learn about as a result. Now, a question might arise. How was its presence known and acknowledged? Well, it seems that even though dark matter does not emit, absorb or reflect electromagnetic radiations or energy, it does have some mass and therefore also generates gravity. This gravity and matter interferes with the visible matter and makes them behave differently than they actually would in its absence. This conclusion is quite similar to the one Zwicky had made back when dark matter was originally theorized. It is this gravity that helps us to detect dark matter through gravitational lensing. If you are wondering what gravitational lensing is, let me tell you that it detects shifts in light produced by distant celestial objects. Next up, let me tell you about the composition of dark matter and dark energy. Well, just like the other aspects, the composition of dark matter is unknown. However, there have been many speculations and theories about it. It is possible that dark matter does not include baryonic matter. However, it is also not absolutely impossible either. If it does include ordinary baryonic matter at all, it's possible that they are all tied up in brown dwarfs or in small dense chunks of heavy elements. This possibility is commonly called massive compact halo objects, or in abbreviated form, MACHOs. Coming to the other possibility and the more common theory, that it is not made up of baryonic matter. It could be composed of particles called neutrinos, which don't make up ordinary matter, axions or WIMPs, that is, weakly interacting massive particles which have weak interactions with ordinary matter and hence difficult to detect. They could also be made up of neutralinos, which are slower and heavier than neutrinos but are currently hypothetical and not yet detected in reality. Last but not the least, dark matter can be of two types: hot dark matter and cold dark matter. Hot dark matter, essentially made up of particles traveling close to or maybe even at the speed of light. Cold dark matter, on the other hand, is made up of much slower moving particles. However, it is thought by astronomers that majority of the dark matter is cold dark matter, as this would not allow matter to come together and form galaxies. So with that, we come to the end of our discussion for today. If you enjoyed this video and learned something new today, do not forget to like, share and comment. If you are new to my channel and find my content interesting, do not forget to subscribe to my channel. That's it for today. Meet you in another interesting episode of the Astronomy series. Till then, bye.